third index, secondary index, and so on, right? So if the indices are going to be ordered, it's known as ordered indices. So for example, we have an employee table with thousands of records, with each record being 10 bytes long, right? So for example, if we are going to sort the record based on the IDs. So if their IDs start with 1, 2, 3 till 1000, and we want to locate or search for a student with ID 543, right? So in the case of a database with no index, we have to search the disk block from the starting till it reaches the record 543, right? So each and every record is 10 bytes long, right? So the DBMS will read the record 543 after reading 5430 bytes, right? So after reading 542 records, then only you will be able to read the 543 record, since there is no index for the records that are present, right? So if there is no index, we need to read 5430 bytes for reading the record with the ID, student ID 543. Whereas if you have an index file, right, you are going to perform searching of a particular record in an index file, and then you are going to directly branch to the particular record in the disk, right? Then let us assume that the index search key occupies 2 bytes, right? So we'll be searching using indexes, and DBMS will read the record after reading 542 cross 2084 bytes, which is very less compared to the previous case, right? So you are going to locate a particular record using indexing as well as without indexing. So if without indexing, you are going to sequentially read the file, right? So a file with ID 543, student ID 543, it can be accessed only after reading 5430 bytes. Whereas if you are going to create an index file, you are going to create an index file. The search key occupies 2 bytes, right? So 542 into 2 bytes, it's going to be 1084 bytes are required to look for the particular search key, and it contains the pointer to the location of the particular record. So whenever you go for indices, you will be able to reduce the speed of locating a particular record in a disk.